Oftentimes, features in a dataset are interrelated, so that it may be hard to determine the actual effect of a certain action on an outcome. Actable AI offers a causal inference analytic to circumvent this issue and explain whether a change in treatment variables actually causes a change to the outcome. Let's say we would like to see the causal effect of employee training on their income. Having uploaded a dataset, either as a CSV file, an Excel file, or by connecting directly to a database, we can then proceed to view the dataset. So, we can see here the table. Okay, there are several columns. Let's get familiarized with all of them. So the first one is self-explanatory. It corresponds to the age of the subject. Black determines if the subject is of a black race. Eduk determines the number of years of schooling. Hisp determines the whether the subject is Hispanic. Married indicates whether the subject is married. This column determines if the employee has a high school diploma. RE74 corresponds to the real earnings in the year 1974. This is the same but for the year 1975, and again this is the same but for the year 1978. And this is actually our target value. Treat corresponds to the indicator variable for the treatment status. Now, when it's true, the subject has been in a training program, whereas if it's false, the subject was not in a training program. So essentially, we want to see if employees who were part of a training program have actually a higher income than those subjects where treat is equal to false, so they did not have any training. So in this case, we're going to try and see the relationship between these two columns. U74 and U75 correspond to the whether the employee was unemployed in 1974 and 1975. Now, with this knowledge, we can then proceed to perform causal inference. So we can then choose our dataset. Okay, here we can then choose our desired options. So first of all, we need to select our time column, if we have one, which will also allow us to filter our rows based on the date and the time. Then we need to select these options here. So we have the outcome variable. So in this case, it will be RE78. The treatment variable, as we mentioned, it's going to be treat. The treatment control, so this is like a control group, okay? So we can set this to false because this is our baseline. The effect modifier, we can choose actually an effect that, so we can compute the causal effect at the observed values of a particular variable. So we can choose, for example, the age. So in this way, we will compute the causal effect over different ages of the employees. Common causes are essentially the features that we want to use. So we have, for example, black, education, Hispanic, married, and no degree. We can also decide to use any filters to reduce the number of rows that we want to work with. Okay. Once we're happy with that, we can go ahead and run it. Now I already have a result trained here actually. Um, so these are the results that we got. So how do we interpret these values? So first of all, we have this graph here, and we are shown the difference between the treatment control. Okay, so we set that to false here, and the value went true. So essentially, we're seeing what is the difference when treat is set to false with respect to when treat is set to true. That is when employees have received training. We also shown the 95% confidence interval. Now we can see that generally the effect when training is performed by an employee, the income increases. Okay, and it actually seems to increase more as the subject becomes older. However, we can also note that in this case, there might also be cases where employees earn less income based on this interval. Okay, there are certain cases where the income is always greater. So, for example, here, age 28, a person receiving training always earns more than when um, the subject did not receive any training. So this is a very useful insight, which confirms that training is generally beneficial to the income of a person. Here at the bottom, then we have the conditional average treatment effect. So essentially here we are seeing the effect modifier's impact on the outcome. So in this case, we use age as the effect modifier, and it's clustered into different subgroups, and we have the mean and standard deviation of each of these groups. Okay, so we can see the um, severity of the effect modifier's impact on the outcome in each case. We can also see the causal graph here. Um, so as we can see, RE78 is our output. Okay, so this is the target value. We also have here treat, which is, as we mentioned, the treatment variable. Blue represents the effect modifier variables. In this case, we used age as our effect modifier, and the rest of these values are corresponding to common causes. So common causes are variables that can affect both the treatment and the outcome, as is shown here. Okay, for example, merit affects both treatment and it also affects outcome. Okay, so actually this influences both variables. Okay, and treat also affects the outcome. So this is why it's important to perform causal inference to remove the influences of all these uh, relationships and focus only on the direct relationships between a variable and the target. We also have the validation tab here, which gives us information on the treatment model and the outcome model. Now, as I mentioned, um, in the case of the causal graph, so we have relationships of a variable here uh, between both the treatment and the outcome. These are confounder variables, so to remove that, we need to disassociate the variables, okay? And to do that, we train two models, one for the treatment and one for the outcome. And here we see a summary of the feature importance of each of these models, okay? So we can see, for example, that in the case of the outcome model, okay, RE78, age is an important feature, as is the education. Also, being black seems to have an impact, okay, in this scenario. This is data captured in 1978. We can also see residual plots here as to the differences between the outcome and the treatment, okay, the outcome and treatment residuals. Finally, we also have the table with our original um, columns, original data for convenience, as shown earlier. All of this is documented in our website, docs.actable.ai, where you can see a description of what is causal inference, why it's important, how it's done, the parameters that can be chosen in the app, and how to interpret the results using an example case study. Okay, so this is very useful if you want to learn more about causal inference and how to use the Actable AI app. That's it for now. Thank you very much for watching. See you again in the next video.